Welcome back to our channel, where today we dive into the fascinating formation and structure of Mira, also known as Omicron Ceti, one of the most intriguing binary star systems in our night sky. Mira, which lies about 300 light-years away in the constellation Cetus, is not just one star but a binary system made up of two stars. Mira A, a pulsating red giant, and Mira B, a small white dwarf. Discovered over 4 centuries ago by astronomers who noticed its unusual brightness changes, Mira has since become a well-known example of a variable star system. Let's explore how this unique pair came to be and why they're so captivating to astronomers. Mira A, the larger and brighter of the two, began as a star similar to our Sun, possibly a bit more massive. Billions of years ago, Mira A formed from a massive cloud of gas and dust that collapsed under gravity, igniting nuclear fusion in its core. For much of its life, it burned hydrogen and was relatively stable. But as the hydrogen ran out, Mira A's core contracted, and the star began to burn helium, causing the outer layers to expand significantly. Today, Mira A has bloated into a red giant over 300 times the size of our Sun, and it's now in an unstable phase of life, resulting in its famous pulsations. These pulsations cause Mira A's brightness to vary significantly over time, sometimes so faint it's invisible to the naked eye and other times bright enough to be easily spotted. The process is powered by thermal pulses within the star, causing it to expand and contract over an 11-month cycle. This variability is why Mira was given its name, meaning wonderful, or astonishing, in Latin. The second component, Mira B, formed from another star in this binary system, which was originally similar in mass to Mira A. However, it exhausted its fuel more quickly, ending its life as a white dwarf. During this process, it expanded into a red giant, shed its outer layers, and eventually left behind its core. Now, as a white dwarf, Mira B no longer produces energy through fusion but still exerts a gravitational pull on Mira A. Mira A and Mira B are locked in a gravitational dance, with Mira B orbiting Mira A at a close distance. Their interaction is especially interesting because Mira A, as it expands and pulsates, is losing mass in the form of gas and dust. Some of this material is pulled toward Mira B, forming an accretion disk around the white dwarf. Over time, this process has created a complex structure of gas and dust trailing the pair as they move through space, something like a cosmic comet tail, which stretches over 13 light-years long. Mira's pulsations, variability, and the interaction between its two stars make it a valuable target for studying late-stage stellar evolution. Observing Mira helps astronomers understand the future of stars like our Sun, which will one day go through a similar red giant phase and may even become part of a binary system like Mira. Additionally, Mira's tail gives scientists clues about how stars shed mass and distribute material into the interstellar medium, a process that eventually enriches new star systems with elements necessary for planet formation and, possibly, life. In time, Mira A will likely shed most of its outer layers, possibly creating a planetary nebula similar to the famous Ring Nebula, and leave behind a white dwarf much like Mira B. The two white dwarfs will remain in a quiet orbit around each other, with the end of their stellar activity marking the last chapter of this remarkable system. Thank you for joining us on this journey through the fascinating life of Mira, the binary star that truly lives up to its name. If you enjoyed this deep dive, don't forget to subscribe for more cosmic insights, and let us know what's stellar stories you'd like us to cover next. Until next time, keep looking up and stay curious.